Salam and welcome everyone. So today we're going to be working on the question on the screen that says the vapor pressure of a substance at 20 degrees Celsius is 58.0 kilopascal and its enthalpy of vaporization is 32.7 kilojoule per mole. Estimated temperature at which the vapor pressure is 66.0 kilopascal. So the first thing you have to note in this question is that we're told the vapor pressure of a substance at 20 degrees Celsius is 58.0 kilopascal and its enthalpy of vaporization is 32.7 kilojoule per mole. Now, you may be tempted to read that first sentence and solve it and then use the whatever you get, the unknown that you solve for, to solve the second part of this question. But I want to tell you that that is the wrong way to solve this. At the end, we're told to estimate the temperature at which the vapor pressure is at 66.0 kilopascal. When you do a lot of physical chemistry question, if you read the first sentence, you're going to think, oh, I have to solve for an unknown and then use that unknown to solve for the second part, which is the estimated temperature, blah, 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 blah. One thing you need to know is that's not what you're supposed to do. You're going to be using a formula called the Clausius-Clapeyron equation. This equation is what you're going to use, and it's a combined equation that takes into account every single variable in this question. So the Clausius-Clapeyron equation can be written in two ways, and we're just going to use one for this particular question, right? You can either have the Clausius-Clapeyron equation to look like this, which is ln p divided by p star is equal to negative change in the enthalpy of vaporization divided by R, okay, which is a gas constant, times 1 over T, 1 over temperature, minus 1 over T star. So that's one way of writing the equation. You could also have another way, which is just P is equal to P star, okay, E minus raised to the power of change in enthalpy of vaporization divided by R times 1 over T minus 1 over T star. So that is basically the two equations. For this particular equation, because we're told to calculate the temperature and we're not told to calculate something like the pressure, it is better for me to use the first equation. So that's the first thing you have to note. If you notice, this question is very different from the other types of question I solve where I would have written all of the parameters and all of that information, but you need the background information in before I can even start with writing the parameters. Now, I wanted to now mention something in the Clausius-Clapeyron equation for you to note. You have to note that P star, okay, is the vapor pressure. I'll just say VP when the temperature, I'll just say temp, is T star. And then P is the vapor pressure. So vapor pressure when temperature is T. So meaning that P star relates to T star and P relates to T. So I want you guys to know that before we start solving. Now we can finally start writing down our parameters. So the vapor pressure of a substance at 20 degrees Celsius is 58.0 kilopascal. So the first one, P star, is what? 58.0 kilopascal. And that happens at 20.0 degrees Celsius. So T star is 20.0 degrees Celsius. Of course, in chemistry, we will have to go from degrees Celsius to Kelvin. So that would be plus 273.15. So that would be temperature is just 293.15 Kelvin. So that's that. And then, of course, if we read the question more, we know that we've been given the enthalpy of vaporization. So the change in enthalpy of vaporization, H, is just simply 32.7 kilojoule per mole. 32.7 kilojoule per mole. So, yeah, that's it. And then we're told the last part of the question, estimate the temperature at which the vapor pressure is 66.0 kilopascal. So we're told to estimate the temperature. So we're supposed to solve for T when the pressure or vapor pressure is what? 66.0 kilopascal. So we have all the information we need now, and we can start using Clausius-Clapeyron equation to solve. So let me rewrite the Clausius-Clapeyron equation. We have ln P over P star, okay, the one we're actually using is equal to negative the enthalpy of vaporization divided by R times 1 over T minus 1 over T star. Yeah, so that's it. So of course, We start. So we have ln P divided by P star. So that would be P, which is 66.0 kilopascal, divided by P star, which is what? 58.0 kilopascal, is equal to negative the enthalpy of vaporization, which is just 32.7 kilojoule per mole, divided by R, which is just simply our gas constant, which is 8.3145 joule per mole Kelvin, okay, times 1 over T, which is temperature, which T, which is what we're looking for, divided by 1 over T star, and we know our T star to be 293.15 Kelvin. So yeah, this is it. We can look at our question and see whatever we can cancel out. We can cancel out kilopascal, kilopascal. We can cancel out mole and mole, and that's all we can do for now. So next you have ln 66 divided by 58 is just going to give you 1.13793, okay, is equal to negative 32.7 kilojoule time, I'm sorry, divided by 8.3145 joule. Well, because this is in kilo, I have to write it out, which is just negative 32.7 times 10 raised to the power of 3 joules, or negative 32 times 10 raised to the power of 3 kilojoules, right? Or sorry, you see, I had to do times 10 to the power of 3 joules because I want to make sure the numerator and the denominator for this part is similar. You can see our gas constant is 8.3145 joules. How can I cancel when my units don't match? So I have to change it from kilojoules to joules. So yeah, that's an important information you should know. Okay, divided by 8.3145 joules per Kelvin. So of course you can cancel out joules here, you can cancel out joules here. So that times 1 over T minus 1 over 293.15 Kelvin. So ln 1.13793 is just simply going to be 0.129211, okay, is equal to negative 32.7 times 10 to the power of 3 divided by 8.3145 would just simply be negative 3.93289 times 10 raised to the power of 3, 1 divided by 1 over Kelvin, right? Let's remember our math from like middle school. 1 divided by 1 over Kelvin is the same thing as 1 divided by 1 over Kelvin, which is the same thing as 1 times Kelvin over 1. So the answer is just simply Kelvin. Do you understand what I'm saying? So we can just simply stop with the complicated units and just put Kelvin here because that's what we're supposed to have. Times 1 over T, okay, minus 1 over 293.15 Kelvin. So that's it. And now we can continue our work. Let me change color just so we have some color. So 0.129211 is equal to negative 3.93289 times 10 to the power of 3 Kelvin. So I am going to use this to expand what we have here. So I'll expand here and then expand here. So that's what I plan on doing. So this times this divided by temperature, then negative times negative here would give us positive. So 3.93289 times 10 to the power of 3 Kelvin divided by 293.15 Kelvin. So cancel out Kelvin, cancel out Kelvin. So that's how it's supposed to be. So you end up with 0.129211 is equal to negative 3.3289 times 10 to the power of 3 Kelvin divided by temperature plus 3.93289 times 10 to the power of 3 divided by 293 is just simply 13. Okay, if you put in your calculator, you get 13.41596. Perfect. Now you can see that with all the math we've been doing so far, we've finally been able to break down our work to this. You see, this is so easy here. So easy, so easy. So, what this is simply telling you is that you can now group like terms, right? So, you have 0.129211, okay, minus 13.41596 is equal to negative 3.93289 times 10 to the power of 3 Kelvin divided by temperature. So that would be negative 13.28675, okay, is equal to negative 3.93289 times 10 raised to the power of 3 Kelvin divided by temperature. So, of course, we're going to cross multiply and we end up with negative 13.28675, okay, temperature, okay, is equal to negative 3.93289 times 10 to the power of 3 Kelvin, okay. So of course you divide both sides by this, so that'll be negative 13.28675 divided by negative 13.28675. So you cancel out this here, cancel out this, and of course, we input this information in a calculator. So temperature, when you have this information to our right and you input that in our calculator, so negative 3.93289 times 10 to the power of 3 divided by negative 13.28675. Of course, if you go from negative, if you have numerator negative, if you have numerator negative, so we're just going to have a positive here. When you do the positive and you do the calculation, the division calculation, you end up with positive 296.001 Kelvin. And of course, because we're chemists, we have to make sure we put everything in the proper number of sig figs. So we have to go back to the question and look at the numerical values given to us. We see that the vapor pressure of a substance at 20 degrees. We see that 20 degrees is 3 sig figs, 58.0 is 3 sig figs, enthalpy of vaporization 32.7 3 sig figs, and this last vapor pressure 66.0 is 3 sig figs. So you have 3 sig fig all around. That means our final answer has to be in 3 sig figs. So temperature is approximately 296 Kelvin. So this is basically the answer to this question. If you have any questions, please put in the comment section. If you have any suggestions or concerns, also put in the comment section. I wanted to mention that I have done a bunch of questions from the Physical Chemistry Atkins 11th edition textbook, and I have done over 90 questions from the thermodynamics portion. So if you're a student who's struggling with anything in physical chemistry, thermodynamics, make sure you watch all my videos. Lastly, I wanted to mention that if you're a student who's struggling in any of your STEM related courses, I help students succeed, whether they're in middle school, high school, or college, in all your STEM related courses. I also wanted to mention that you have to email me at shahabitutoring@gmail.com if you would like the tutoring. It is either a one-time booking, maybe you just have like an assignment or you need me to explain something, or you want ongoing tutoring for a particular class. If you are one of those two students, please email me at shahabitutoring@gmail.com and I'm going to be there to help you. By God's grace, I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.